Alright, hey guys. So we're going to be utilizing a program called Logger Pro. The symbol for it is right here. Okay, now I'm doing this on a Mac. You guys will be doing it on a Windows, but it functions pretty much the same. So in this video I'm going to show you how to plot data and get a best fit line using the program, and then we'll go from there. So I have a sample data set over here. Usually you'll have this written in your notebook after an experiment. But the experiment is how temperature affects the number of chirps of crickets. Now these are average values. I already did that on my own. So in order to utilize this data, I'm going to open up Logger Pro so I get this screen. And I want to first start by labeling the data table before I enter any data at all. So I'm going to double click on the X column. This is going to be where the independent variable goes. And for my experiment, the independent variable was temperature. And for short name, I'm just going to abbreviate the word just with a single letter or maybe a double letter. And for units, that was measured in degrees Fahrenheit, so I'm just going to do F, click done. And you'll notice that it changed my graph down here to temperature. I'm going to do the same thing with the dependent variable. We had cricket chirps, so I'm going to abbreviate that CC. And the unit, well, since it's a counting unit, I'm just going to call it chirps because that's literally what I'm counting. Cool. So now I've got cricket chirps versus temperature. Alright, now here's where you would just go in and type in numbers from your data table. Since mine's in Excel, I'm just going to copy and I'm going to paste it over from Excel, and so I get all my data graphed right away. Now sometimes you'll want to change the scales of the axes, and we can do that by clicking and dragging. If I put my mouse arrow on my axes, you'll notice that it changes to this symbol that it currently is right now, and I can click and move the scale. However, we always want to leave the 0, 0 point on the graph. Always. So if I go to auto scale, what you'd find is that the 0, 0 disappears, and that's a problem. So I'm not going to scale my graph. Okay. Now, this data is good. However, I do need to fit it with a trend line, because that's what we are trying to do. We want to find what's the trend so that I can create a model for how temperature affects cricket chirps. So if I click on the data, oh sorry, wrong program. If I click and drag to highlight the data, that's what I meant, you'll notice that all the data points are highlighted here as well. All right, I can go up here and I can pick a fit. Now, this is where you will have to use your own brain power and work with your group. I'm looking at this data and I think it looks linear. Like that as one goes up, the other goes up by an equal amount. So I'm going to go up to this symbol, linear fit, and if I click on that while the data is highlighted, the computer will automatically generate a best fit line. Now if you come to this box, here's where all that information about that line is. I have the symbol, the short name CC, equal to the slope of the line, which is given right below it, times the temperature plus B, the y-intercept, which is given below the slope. Okay. You'll notice that the units are given for the slope right away, so are the units for the y-intercept. So in your lab notebook, you would make a sketch of this graph and a sketch of the best fit line or best fit curve that you put in to your graph, and then you would write out this information, right? CC equals this slope value times temperature T plus the y-intercept. And then from there your group would analyze and try and interpret some physical meaning. Just real quick, not every relationship is linear. If you were to come across a relationship that you and your group don't think is linear, instead of clicking linear fit up at the top, you would click curve fit. And I'm just going to show you what that looks like. If I click on curve fit, I come up with this monstrosity, and I'm given a list of different types of fits that could exist. It would be up to you and your group to try and figure out what trend it might be. So for example, we had said linear, so if I click on the linear button, I could try the fit, and I would get a little preview of what it's going to look like. If maybe you and your group thought, well, that looks like a quadratic equation, right, something squared, I could click on the quadratic, I could try the fit, right, and then it would fit a quadratic equation, right? Likewise, if I thought it was cubic, etc. You notice when I tried the quadratic that it came up with the coefficient numbers for me. This is stuff you would write that expression into your journal, and then you have to make physical sense of it as we share with the group. Okay? All right. Oops. If I want to get rid of something, by the way, I just click on this. Computer's being slow. I just click that away and it disappears. Okay? And there you go.